Howdy, my name is Anthony Kukla, and this will be my final project for Chem 120, where I will be testing the solubility of 3 different waters. I have the water from my dorm faucet, I have water from the dorm hallway water fountain, and water from a water bottle from the store. I'm assuming that these are going to be of 3 different purities, with the one from the faucet being the least, and the one from the water bottle being the most pure. I will be testing this using uniodized salt. Each of these cups has 1 cup of each type of water in it, and I will be adding the salt in 1/4 teaspoon increments. I am now going to start adding the salt in 1/4 teaspoon increments and see which one is able to dissolve the most. In this first cup, I found that I was able to dissolve just under 5 teaspoons of the salt into the water, between 4.75 and 5 teaspoons. It was closer to 5, so I'm going to say it was around 4.93 teaspoons of salt into the water. Now that I've done the water from the faucet, I'm going to do the water from the hallway. In my cup of the water from the water fountain, I was able to dissolve between 7.25 and 7.5 teaspoons of the salt into it, and it was closer to 7.5, so I'm going to say it was 7.4 teaspoons of salt into the water. Last, I will do the water from the water bottle. In the third cup, which is from the water bottle, I was able to dissolve between 8.75 and 9 teaspoons of salt into the water, and it was closer to 8.75, and it was right around 8.84 teaspoons of salt. Now that we have all of our data, we are able to make our calculations. At the top of the page, we have our conversion factors, which we will use to make the calculations. All of the water was at 68.7 degrees, which was the room temperature, which is 293.5 Kelvin. For our molarities, we got 1.49759 moles per liter for the first cup, 2.24790 for the second cup, and 2.685336 for the third cup. Now that we have our molarities, we can calculate our solubility constants. Using an ice table, we find that the constants will be equal to our molarities squared. And doing the math, we find that our constants are 2.2 for the first cup, 5.1 for the second, and 7.2 for the third with our significant figures.